Third one is the quantity. What is the quantity that actually is made to produce the flow? Right? In electrical systems, it will be charge. Right? So capital Q, charge or change in charge, if you like, delta Q. In fluid systems, it is mass. M, mass of the fluid, which is density times the volume of the fluid, basic formulas. In thermal systems, it is thermal energy, so quantity of energy that is stored and that changes as the flow of heat takes place from a hotter system to a colder system. And this is typically given as M times C times delta T. Okay? M is the mass of the thermal mass of the system. C is some kind of a specific heat, constant pressure, constant volume. Delta T is obviously temperature difference. Mechanical systems, mass of the body or moment of inertia. IG. Two more things I want to talk about before I let you all go. Resistance and capacitance. Electrical resistance is easy, right? It is nothing but the Ohm's law that is applied here. So R is delta V divided by I of t. This is all analogy, okay? This is not, they are not as if they are equal to each other. This is just an analogy. So if I just blindly draw an analogy between electrical and fluid systems, I don't need to think twice. Fluid resistance is nothing but the effort variable, which is delta P, divided by the mass flow rate. That's it, no derivations required. Okay? So this is fluid resistance. Why do you have fluid resistance? Anybody? Yes, yes. You.
Friction.
Fantastic. Friction. That's it. That's all it is. There's fluid resistance because when fluids flow through pipes, there's going to be friction losses taking place. And so that is encapsulated as the change in the pressure divided by the volumetric or the mass flow rate. Okay? So thermal systems are also easy. It is the effort variable divided by the rate of heat transfer. This is thermal resistance. And of course, we don't define resistance for mechanical systems. It's kind of a moot thing. Capacitance, right? That's the last one, so I'm going to pull this panel down. This is all you need to remember from system dynamics. Even if you do not learn thermal systems, this is sufficient. Thermal resistance, effort by the flow. Delta T, heat rate. Capacitance, I'll define it here in the next panel. Last one for today. So this is the variable. We don't define capacitance for mechanical systems. It's also not needed from that perspective. So capacitance. Capacitance for electrical systems is related to charge, right? So the change in the charge is proportional to the change in the voltage, and the constant of proportionality for the capacitor is the capacitance. So delta Q is equal to C times delta V. This is change in the charge, in quantity of charge. Or you could also write it as dq, c times dv if you want to write it in the differential form. Okay? Fluid systems. Quantity in a fluid system is the mass of the fluid. And change in the quantity is delta M. So I'm going to have delta M. Fluid capacitance, same symbol, unfortunately. And the voltage difference in electrical systems is analogous to pressure difference in fluid systems, or in a differential form. So that's C